So in these next set of videos, I'm going to be going through a few questions from the chapter 10, exercise E and exercise F. So this is the first question in 10E question. So this question 1. It says two particles are of masses 8 kilograms and 2 kilograms, respectively, are connected by light inextensible string. The particles are on a smooth horizontal plane. A horizontal force of magnitude F newtons is applied to P in the direction away from Q. And when the string is taut, the particles move with an acceleration of 0.4 meters per second squared. So what I suggest is always read the question once to give you kind of an idea of what the question looks like, and then you can start drawing it when you read it a second time. So it's two particles P and Q. So let's call this one P, this one Q, of masses 8 kilograms and 2 kilograms. So you can put your weight force in. Respectively, are connected by a light inextensible string. The particles are on a smooth horizontal plane. And so because it's a smooth horizontal plane, there is no friction. A horizontal force of magnitude F is applied to P in a direction away from Q. So there must be a force going this way. And when the string is taut, the particles move with an acceleration of 0.4 meters per second squared. So if F is pulling to the left, then the particles must move with an acceleration of 0.4 to the left. So this is our diagram. The diagram is probably the most important thing in any of these kind of questions. So now let's have a look. Find the value of F. In order to do this, we need to complete all the forces on our diagram. Okay, so we've got our weight, we've got the forward force applied to P, and because there's a piece of string, whenever there's a piece of string, you're going to have a tension. Tension is a pulling force, so it always goes away from the particles. So there's my tension. So there's one tension pulling P towards Q and another tension pulling Q towards P. You also have your reactional forces because they're both these particles are on a surface. Right, so that's my force diagram is complete. Now I'm ready to answer this question. We need to find the value of F, which is over here. In order to do this, what we need to do is we need to treat this whole two particle problem as if it was one system, so just one particle. And we can do this because both the particles are moving in the same direction and they're moving together. The string is taut, and as P moves forward, Q also moves forward. Okay, so their combined mass is 10 kilograms, so they're going to have a weight of 10 G. They're going to have a net reaction, so I'm just going to call that R. There's a tension going to the right and a tension going to the left, and because both these tension values are the same, they're going to cancel out. And then you've got a forward force of F newtons. And this whole system is accelerating to the left at 0.4 meters per second squared. Now we can apply Newton's second law, which is F equals ma. This F here, notice in Newton's second law, its force is equal to mass times acceleration. And force refers to the net force. And net force, you can calculate, the notation we usually use is R for resultant. And I'm going to take to the left as positive because the whole system's moving to the left. And the only force going to the left is F. And there's no force going to the right, so it's just F as my net force. And that's equal to mass, which is 10 times acceleration 0.4. And so we can calculate F as equal to 10 times 0.4, which is 4. newtons. So that's our answer to part A. And in part B, they're asking us to find the tension. Whenever they ask us to find the tension acts, each individual tension acts on the particle itself, and just acts on one of the particles. And so we need to look at an individual particle in order to calculate tension. I'm going to choose Q, but later on I'll quickly do P as well, just to show you it doesn't really matter which one you choose. So Q has a tension going to the left, has a reactional force, and has a weight component 2g, and is accelerating to the left with 0.4. So similar to what we did in part A, if we find our resultant going to the left, the only force acting on this is T, so we've got T going to the left, and that's F net, and that's equal to mass times acceleration, and so T is equal to 0.8 newtons. I'll just quickly show you with P as well. If I take in P, P has got an F going to the left, T going to the right, or P going up, and has a weight of 8g. Again, taking the resultant to the left, it's got an F Newton force going to the left and T going to the right, so we're going to do F minus T to get the resultant, and that's equal to mass, which is 8, times acceleration, which is 0.4. Should put that in there. We go. F was 4, and if we take the T to the other side and bring 8 times 0.4, which is 3.2 to the left, so we get T equals 0.8. So as I said, whichever particle you choose, you should get the same answer each time. And lastly, it says in part C, explain how the modelling assumptions that the string is light and inextensible is used. So the fact that the string is light this means that the tension is the same throughout. So the tension is the same throughout the whole string. And also you can mention that the mass of the string is negligible, or we don't take it into account. And the fact that the string is inextensible this means that the acceleration of the two particles is the same. These are quite common questions of what does it mean if it's light, or what does it mean if it's inextensible, and we just need to learn these two reasons. Okay, there will generally be a 1 mark or 2 mark at the end of a question. And so that's exercise 10E question 1.